This is part 2 of chapter 5 test review. I'm going to continue with number 11 because the last video cut off there. A bag contains 1 red marble, 2 blue marbles, 4 orange, and 3 purple marbles. The marble is drawn and not replaced. That's very important. When a second marble is drawn, determine the probability of each event. So, the probability of drawing a red the first time is you have 1 red marble out of 10. So your chances of drawing a red marble is 1 out of 10. Remember, she did not replace it. So the second time she draws in, she wants to draw an orange. So there's 4 orange. So she has 4 chances of drawing orange. But how many marbles were left in the bag? Because she did not replace them. That would be 9. Multiply across and reduce. Number 12. The spinner below is spun twice. Determine each probability. Even, then even. So the first time that you spin, what are your even numbers? 2, 4, 6. So you have 3 even numbers out of how many chances or spots on the spinner? 7. That was your first spin. On your second spin, you have 3 chances again to land on even out of 7. Multiply across. Number 13. 7 cards are numbered from 1 to 7, placed in a box. 1 card is selected at random and not replaced. Another card is randomly selected. What is the probability of selecting 2 odd numbers? Well, we have 1 through 7. 1, 2, 3, 4, 5, 6, 7. Okay, we have odd numbers. 1, 3, 5, 7. So the first time you're going to reach in the bag or the box and you're going to draw out a card. You have 1, 2, 3, 4 chances of it being odd out of how many chances? 7. Multiply that. Remember, this card was not replaced. So the next time, if you drew an odd card, what are your chances of drawing another odd card? If I drew 1, then my chances are 1, 2, 3 out of how many? 1, 2, 3, 4, 5, 6. Because she did not replace the card. Remember, you have to simplify your answers. So don't forget that. Number 14. A bag contains 1 red, 2 blue, 4 orange, and 3 purple marbles. A marble is drawn and not replaced. Again, keyword not replaced. Circle, highlight, whatever. Then a second marble is drawn. Determine the probability of each event. That the probability of you drawing purple, so how many purple marbles? There's 3 purple marbles. So 3 out of how many were in the bag? 3 plus 4 plus 2 plus 1. Okay, she did not replace the marbles. She didn't replace them. So the next time she draws, and she still wants to draw a purple one, the odds of her drawing a purple one, if she drew 1 the first time, now she's down to 2 marbles of purple marbles. So now she has 2 chances out of how many marbles were left in the bag, because remember, she didn't replace that marble. It would be 9. So multiply across and reduce. Number 11. Oh, no. 15. Use the spinner below. Determine the probability of each event. Write as a fraction in simplest form. Important information. We're looking for something. What's the probability of it not being a vowel? Well, your vowels are A, E, I, O, U. There's an A, there's an E. It can't be one of those. So what's the probability of it landing on something that's not a vowel? 1, 2, 3, 4. How many total were there? 1, 2, 3, 4, 5, 6. Now simplify that. Number 16. Sohan rolled a number cube 90 times. She rolled the number 6 a total of 18 times. Compare the theoretical and the experimental probabilities of rolling a 6. So you need to write experimental and then you need to write theoretical. Remember, your experimental is when you actually do the event. Like in class, we took turns rolling the dice, drawing out of a bag, doing a spinner. That is your experiment. We actually did the activity. But theoretical is in theory. What would happen in theory? We didn't prove it, but what should happen in theory? So this is a key number for your experimental. Okay, how many times did they roll the number cube? A total of 90 times. And she rolled the number 6 a total of 18 times. But in theory, what were the odds of her rolling a 6? In theory, she had a cube, okay? Don't judge. She had a cube, and when you have a cube that's labeled, it's going to have 6 sides. So, what's the theoretical probability that she's going to roll a 6? Well, if it's labeled 1 through 6, she has 1 chance out of 6. Now you need to simplify this fraction and see if they're alike, because you're going to compare them. What are her best odds? The experimental or the theoretical? Number 17. A jar contains 5 blue marbles, 6 yellow marbles, 4 green marbles. What is the probability of randomly choosing a yellow marble, not replacing it, and then choosing a blue marble? Okay, you have 5 blue, 6 yellow, and 4 green. What's the probability of randomly choosing yellow? There are 6 yellow marbles. You have 6 chances out of how many? 15. She did not replace it. And then choosing a blue marble. How many blue marbles are there? 5. But how many was left in the bag? Because she did not replace it. She had 14 left. So you can either simplify this before you're going to multiply, or you can multiply now and reduce later. Either way, it has to be in simplest form. You're going to have to reduce either way. Number 18. Bailey tossed a coin 10 times. The results were 7 heads and 3 tails. Compare theoretical and experimental probabilities of tossing heads. Okay, so theoretical, which means in theory. In theory, what should she come up with? But the experimental, what actually happened? Okay, and compare the two. Number 19. There are 100 prize tickets in a bowl, numbered 1 to 100. What is the probability that an even numbered prize ticket will be chosen at random, not replaced, then an odd number prize ticket will be chosen? So first even, then odd, and it was not replaced. Does this represent an independent or dependent event? So I'm going to let you do this one on your own. By now, I hope I've done enough examples. There are 100 prize tickets in a bowl, numbered 1 to 100. What is the probability that an even number prize ticket will be chosen at random, not replaced, than an odd one? Okay, so remember, it was not replaced. I would go back and find one that was not replaced to help show you how if you can't remember. But then you have to explain, does this represent an independent or dependent event? And explain your answer. And I believe this is the last question. Use a problem-solving model to solve each problem. The table shows the results of an experiment that Jane conducted using a box of colored discs. She repeated the process of selecting one disc, noting its color, and returning it to the box. Based on experimental probability, how much more likely is it that the next disc drawn will be purple than green? Not or, than. Okay, so you need to know how many total discs that she put in the box. So you need to add all of these up, get your total discs that were in the box. You need to compare it of her drawing purple. Compare it to when she would draw green. Okay, and she returned it to the box. So the total remains the same because she returned it. That's your hint. All right, the last two are up to you. Hopefully you can get them all done. And if you have any questions, we'll be in the room in the morning. If we're not there when you get here, please wait by the door. Thanks.